Hello and welcome to my channel. Someone sent me a message asking me if I had looked into artificial intelligence. So I thought, well, let's look into it. And it's really good to be open-minded and consider different possibilities. So I'm going to just show you some of the things that I read that I found interesting. Now, string theory isn't something that I really believe in, but I found this interesting. In a nutshell, string theory and multiple dimensions. One of the coolest aspects of string theory is that in order for it to be true, it requires the existence of multiple dimensions. And it's not just an out there idea that only a few scientists support. It's studied by leading physicists around the world. So does that mean there's a parallel world with an alternate you? Not necessarily, though that is fun to think about. And it says when you pluck a violin string with one finger and then stuck another finger in the way of the vibrating string, the note you would hear would be cut short. That's basically why we need multiple dimensions if string theory is going to prevail. The way strings vibrate determine what type of particle it is. Physicists also discovered is that the strings need more space than just our three dimensions to express all their vibrational patterns. And okay, go away. There it is. Okay. And then here on this website, a multi-dimensional breakdown. Let's see. Artificial intelligence is weak, strong. Okay, let's see. We want it to do this. We want it to think like a human, act like a human, think rationally, and then it mentions like playing a chess game. Now, see, that makes me nervous because if you've ever played chess with a computer's far more intelligent than I am, so I don't know. Act rationally. Of course, we want it to act rationally, but what we consider rational may not be what something that has a completely different way of thinking considers rational. Okay, so artificial intelligence is about logical reasoning, knowledge representation, planning and navigation, communication, and perception. Major areas of research. There you go. Anyway, on to the next one. Oh, and here's this says, there's just a few different dimensions to view artificial intelligence. We use a number of these ways to think about it. So I'm going to the next tab. So this is relatively easy to write computer programs that seem able in severely restricted contexts to respond fluently in a human language to questions and statements. Although none of these programs actually understands language, they may in principle reach the point where their command of a language is indistinguishable from that of a normal human. Okay. Artificial intelligence versus machine learning versus deep learning. Artificial intelligence, machine learning, and deep learning are three terms often used interchangeably to describe software that behaves intelligently. However, it is useful to understand the key distinctions among them. You can think of deep learning, machine learning, and artificial intelligence as a set of Russian dolls nested within each other, beginning with the smallest and working out. Deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence, which is an umbrella term for any computer program that does something smart. In other words, all machine learning is artificial intelligence, but not all AI is machine learning, and so forth. Here are a few other definitions of artificial intelligence. A branch of computer science dealing with the simulation of intelligent behavior in computers. The capability of a machine to imitate intelligent human behavior. Imitate it. A computer system able to perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. Decision making. An idea from physics helps artificial intelligence see in higher dimensions. See, so this is where this is going. This is going into the realm of higher dimensions. Computers can now drive car, beat world champions at board games like chess and Go, and even write prose. The revolution in artificial intelligence stems in large part from the power of one particular kind of artificial neural network, whose design is inspired by the connected layers of neurons in a mammalian visual cortex. These convolution neural networks, CNNs, have proved surprisingly adept in learning patterns in two-dimensional data, especially in computer vision. So CNN are convolution neural networks. Let's see what this says. Already, they have greatly outperformed their predecessors in learning patterns and simulated global climate data, which is naturally mapped onto a sphere. Escaping flatland. Extending. Let's see what they're. A working theory, a theory of gauge. Let's see, it's so generalized that it automatically incorporates the built-in assumptions of previous geometric deep learning approaches like rotational, let's see, which let neural networks recognize a single 3D shape bent into different poses fits within it. Gauge equivariance is a very broad framework. It contains what we did in 2015 as particular settings. A gauge CNN would theoretically work on any curved surface of any dimensionality, but Cohen and his co-authors have tested it on global climate data, which necessarily has an underlying 3D spherical structure. They use their gauge, let's see, to construct to detect cyclones in the data, 74% accuracy last year. Cyclones with 97.9% accuracy. A climate scientist who uses deep learning said he'll continue to pay attention to gauge CNNs, that aspect of human visual intelligence, spotting patterns accurately, regardless of their orientation, is what we'd like to translate into the climate community. Right here it says we're analyzing data related to the strong nuclear force, trying to understand what's going on inside of a proton. The data is four-dimensional, he said, so we have a perfect use case for neural networks that have this gauge equivariance. Okay, so there they are going into four-dimensional. This right here, teaching about the fourth dimension. Physicists have used analogies like drawings of something called hypercube and even 19th century novella Flatena by Edwin Abbott Abbott. The book imagines two-dimensional beings living on a planar world that has only length and width, unable to perceive a third dimension. The Flatlanders see only one plane of three-dimensional visitors, kind of like how computed tomography or magnetic resonance imaging shows the body in slices, two slices through a leg, one a few millimeters up from the other look almost the same, but a slice through the waist or chest gives a very different picture. We can relate to this analogy, imagining our three-dimensional environment as just one of our infinite number of slices of a four-dimensional environment. But moving beyond four dimensions, it gets even weirder and very hard to visualize. The main theory here is called the M theory, which is a theory in physics that unites various types of what's called superstring theory. In the M theory, there are a bunch of dimensions, either 10 or 11, depending on who explains it to you, in addition to the three we're familiar with, there are compact dimensions. It's R related to a phenomenon called branes, which is spelled different than the word brain, that vibrate like strings, but what's most relevant to this discussion is that the extra or compact dimensions don't necessarily have to remain compact like a jack-in-the-box. It might be possible to unpack the extra dimensions. Okay, and this website right here is, if you want to look into this and read more about this, there it is. Okay, multidimensional brains. As explained by scientists, every single neuron within our brain can interconnect to an adjacent one in a particular way in order to form an object with intricate connections. Interestingly, the more neurons join in with a click, the more dimensions that are joined to the object. With the help of algebraic topology, which experts were able to model the structure within a virtual brain. A virtual brain produced with the aid of computers. Later, experts carried out tests on a real brain tissue to verify the results. After researchers included stimulus into the virtual brain tissue, they found that clicks of progressively higher dimensions compiled. They discovered that in between these clicks were empty spaces like holes or cavities. And if you want to read more on this, scientists find evidence of multidimensional universe inside our brain. An idea from physics helps artificial intelligence see in higher dimensions. Computers can now drive cars, beat world champions at board games like Chess and Go, and even write prose. The revolution in artificial intelligence stems in large part from the power of one particular kind of artificial neural network whose design is inspired by the connecting layers of neurons and the mammalian visual cortex. These convolution neural networks, CNNs, have proved surprisingly adept at learning patterns in two-dimensional data, especially in computer visual tasks like recognizing handwritten words and objects and digital images. Whoops. I think we've already covered this. Understanding a 10-dimensional universe. The 4 dimensions we experience could be just the beginning. When someone mentions different dimensions, we tend to think of things like parallel universes, alternate realities that exist parallel to our own, but where things work or happen differently. However, the reality of dimensions and how they play a role in the ordering of our universe is really quite different from this popular characterization. Well, that's a bummer. To break it down, dimensions are simply the different facets of what we perceive to be reality. We are immediately aware of the 3 dimensions that surround us on a daily basis, those that define the length, width, and depth of all objects in our universe. Beyond these 3 visual dimensions, scientists believe that there may be many more. In fact, the theory framework, 10 different dimensions. Let's see. The 3rd dimension is depth. Beyond these lies 7 dimensions. See, I think one of them to find the 3rd and 4th dimension as time and space on another one of the websites I've already viewed, but I don't think I scrolled over that. So the 4th dimension is time, which governs the property of all matter at any given point, along with the 3 other dimensions. See, one of them I believe is time. According to string theory, the 5th and 6th dimensions are where the notion of possible worlds arise. If we could see on through to the 5th dimension, we would see a world slightly different from our own that would give us a means of measuring the similarity and differences between our world and other possible ones. In the 6th, we would see a plane of possible worlds where we could compare and position all the possible universes that start with the same initial conditions as this one. In theory, if you could master the fifth and sixth dimensions, you could travel back in time or go to different futures. In the seventh dimensions, you would have access to the possible worlds that start with different initial conditions, whereas in the fifth and sixth dimensions, the initial conditions were the same and subsequent actions were different. Here, everything is different from the beginning of time. The eighth dimension again gives us a plane of such possible universe histories, each of which begins with different initial conditions and branches out infinitely. That's why they are called infinities. Okay. See, and I believe that on another page that it said time, so I don't know. Right here, one of the unique and most useful features of Lisp is an artificial intelligence language is the ability to assign properties to atoms. For example, any object, say an atom, which represents a person, can be given a number of properties which in some way characterize the person, such as height, weight, sex, color of eyes and hair, address, profession, family members, and so on. Property list functions permit one to assign such properties to an atom and to retrieve, replace, or remove them as required. The function putprop assigns properties to an atom. It takes three arguments: an object name, an atom or property or attribute name, the property or attribute value. For example, to assign properties to a car, we can assign properties, let's see, where values return, the object car will retain these properties until they are replaced with new ones or until removed with the function which takes two arguments, the object and its attribute. In other words, properties are global assignments. To retrieve a property value such as the color of the car, we use the function get, which also takes the two arguments, object and attribute. Okay. The property value may be an atom or a list. It is an assignment function which also takes two arguments, the first of which may either be an atom or an access function like a car and get, and the second value to be assigned. When the first argument is an atom, it behaves the same. Let's say it simply binds the evaluated second argument to the first. When the first argument is an access function, places the second argument, the value, at the location accessed by the access function. As we shall see in later chapters, property lists provide us with a convenient mechanism with which to represent knowledge. One such representation is a conceptual network where objects or attributes and relations to other objects are easily expressed. Which I don't think I need to study more on what that means. Arrays. Single or multiple dimension arrays may be defined in LISP using the makeArray function. The item stored in the array may be any Lisp object. For example, to create an array with 10 cells named myArray, we bind the unquoted name to an array using with the makeArray function and a specification of the number of cells. Okay, what is arrays? A multi-dimensional array is an array with more than one level or dimension. For example, a 2D array or two-dimensional array is an array of arrays, meaning it is a matrix of rows and columns. Think of a table. A 3D array adds another dimension, turning it into an array of arrays or arrays. So who knows what a computer could do, because the computer's smarter than me, and I'm sure it can understand this better than I could. But I know I used to have dark brown eyes when I was little, and now I have green eyes. So that's kind of crazy and kind of creepy and kind of scary a little bit. Although I wanted to have green eyes and I like having green eyes. My eyes turned green when my oldest son died, but they once used to be dark brown. And apparently it runs in my family now, which I never knew. So anyway, Here's a Bible scripture. All things are full of labor. Man cannot utter it. The eye is not satisfied with seeing, nor the ear filled with hearing. The thing that hath been, it is which shall be, and that which is done is that which shall be done, and there is no new thing under the sun. So, if there are multi-dimensions and our computers are learning how to see in multi-dimensions or even create multi-dimensions or see that they're there or it's in our brain and they can see it in our brain, then it's already been there. So when I think about things like in the Mandela effect or as they call it, or how I remember things differently and what are the possible causes, then I just thought this was really interesting and I thought I would like to share it with you. So please leave comments and let me know what you think. And if you have anything else that you find interesting, please let me know what it is so I can read up on it. Thank you for tuning in to my channel. Bye bye.